Video on coordinate geometry of the line, we're going to be looking at slope. Slope is a measure of steepness. So the steeper a line, the bigger its slope. There are different kinds of slope. This line is sloping up, so it has a positive slope. It's important to note that this line is sloping up when I read it from the left. So I always imagine we're looking at a graph that I'm starting on the left-hand side and looking at it from that position. So looking at it from here, the line is sloping up. If a line has a positive slope, we say the line is increasing. This line is sloping down. What do you think I could say about its slope? Well, a line that slopes down has a negative slope. And if a line has a negative slope, we say the line is decreasing. Here we have a horizontal line. What do you think I could say about its slope? Well, it's not sloping up and it's not sloping down. So its slope won't be positive or negative. So what's in the middle between the two of those? Well, it has a slope of 0. So a horizontal line has a slope of 0. And since its slope isn't positive or negative, it's not increasing or decreasing. There are a couple of different ways of calculating slope. And the first one that we're going to look at is finding the slope from a grid using rise over run. So let's look at an example. So here I have a line on a grid and I want to find its slope. So the first thing that I want to do is I want to identify some point that's on the line that is at the vertex of the grid. So I want to figure out a point basically that's a corner at a corner of one of the boxes of the grid. There's a couple of options here for that, and I want to pick 2 such points. So I've picked these 2 points, and now I'm going to use these with the grid lines to draw a triangle, just like this. From this triangle, I'm going to identify 2 things, the rise and the run. The run is the horizontal distance across the bottom of the triangle, and the rise is the vertical side of the triangle. And I'll just count how many boxes long each of these are to get their values. So in this case, for example, the run just goes 1 box across. So the run is 1, and the rise goes 2 boxes up. So the rise is 2. So now to find the slope of this line, I'll just put the rise over the run. So in this case, that's 2 over 1. And obviously I can write 2 over 1 as just 2. Slope tells me how many boxes up I go on the line for each 1 box that I move to the right. And you can see here quite clearly in this example that for each 1 box I move to the right, I go up 2 boxes. And this continues along the rest of the line. So if I was to relocate myself at this point here now and go 1 box across, I'd have to go 2 boxes up again to stay on the line. A little bit of notation now. We don't tend to write the full word slope down when we're doing calculations in maths. Instead, we have a letter that stands for it. And for slope, that letter is M. So in this particular question, M was equal to 2. And just as a final thing to note, this line was sloping up. It has a positive slope, and its slope is a positive number, 2. Okay, so here's a question for you. So here's a line on a grid. Now, I hope you can see this clearly enough. See if you can figure out where to put a point, or 2 points really, on this line so that they are in the corners of the grid boxes. And then see can you use that to find run and rise and work out your slope. Pause the video here, give it a shot, and then I'll talk you through it in a second. Okay, so I've marked in my 2 points and they're right in the corners of grid boxes. Now I'll draw in my triangle and I'll note my run and rise. In this case, the run is 2 and the rise is 3. So the slope is rise over run. And in this case, that's 3 over 2. And I'm quite happy to leave this as an improper fraction. We don't tend to write our slopes as decimals. So m equals 3 over 2 here. Again, notice that it's a positive value because the line is increasing. And of course, we know that 3 over 2 is 1.5. And just to put it in context again, for every 1 box that I move across, I'd have to go up 1.5 boxes to stay on the line. Across 1 box, up 1.5, across 1, up 1.5. So the slope is 1.5 or 3 over 2. Right, let's look at a second example. So here we have our line. Again, I'm going to mark 2 points on my line that are at the vertices of the grid. Any 2 will do as long as I'm sure they're passing right through the corners of the boxes. And then I'll draw in my triangle and I'll mark in rise and run. So this time run is 2. And it seems funny to call this distance rise because actually I'm not going up, I'm going down, but I'm still going to call it rise, except that I'm going to make it be a negative value. Just note that run should always be positive, but rise can be positive or negative depending on the line. So in this case, my slope is minus 2 over 2, which I can cancel down to get minus 1. And of course, notice that this line is sloping downwards, so I'm not surprised to get a negative slope for it. So here's a question for you then. Can you find the slope of this line? Pause the video here and give it a shot yourself, and then play and see if you're correct. So I've chosen these 2 points, but just note that I could equally have chosen this point here because it also is a point where the line is passing through a vertex of the grid. Now I'll draw my triangle and I'll note my rise and run. So this time my run is 2, and again remember that the run is always a positive value. And again I've got a line that's sloping down, so I'm dropping down as I move along the line. My rise in this case again is going to be a negative value, and in this case it'll be negative 4. And now I'll fill it into my formula. My slope will be minus 4 over 2, which I can cancel down to minus 2. And again notice that as I go across one box I have to drop down 2 boxes to stay on the line. Note that even if you had chosen this point instead, that you should get the same answer of minus 2 for the slope of this line.